Hey guys, how's it going? So this is LeetCode problem number 1768, merge strings alternately. It's part of the LeetCode 75, which, if you don't know, it's like 75 LeetCode problems that just are meant to help you for technical interviews. But yeah, this is definitely, I think, one of the easier problems. So we'll go and get through it real quick. So you're given two strings, word one and word two. Merge the strings by adding letters in alternating order, starting with word one. If a string is longer than the other, append the additional letters onto the end of the merged string, return the merged string. So like here it gives us word one, word two, which word one is ABC, word two is PQR. So we do A, P, B, Q, C, R. And then right here, since word one is less than word two, we do A, P, B, Q, but then we just append RS the end of it since there's no more letters to alternate with within word one. Um, and same with word one and word two. Okay. It's pretty easy. So we're gonna go ahead and get the max, or we'll say the biggest word, and we're gonna take the length of word one and the length of word two. And the reason why we do this is so that, let's go ahead and initialize our new word. The reason that we do this is for whenever we're looping through our words and we're appending them and we're alternatingly appending them to our new word variable. That way we'll make sure that we go through our biggest word and we don't leave anything out. Because if we were to only go through our smaller word, then basically what would end up happening is the last letters of the other word wouldn't get appended. So we'll say if I is greater than the length of word one, or well, no, if I is less than length of word one, we'll do word plus equals word one of I. And then we'll do if I is less than the length of word two. We'll do the exact same thing. We'll do word plus equals word two of I. And then we're just going to return our word. Let's run it. Submit it. Okay, so really good runtime, decent memory, but overall it's pretty good space-time complexity. Um, linear time complexity linear time with it having having just a one for loop. But let's go over this real quick. So first off, we made this biggest word variable, and we set it equal to the bigger length of word one and word two. Like I said earlier, that's just to make sure that we loop through our biggest string, or I should say the string with the most characters in it, to make sure we get through that whole string. And then we initialize this word string right here. We just made it equal to an empty string. And then here's us looping through our biggest word variable. And basically what we're doing here is we're making sure that at the current index that we're on, it is less than the length of both strings. And we do that because in order to be able to successfully loop through each string without getting an out of bounds error if we have a smaller one, we need to make sure and verify that the I value is still below the max amount of indexes in that string. And then we're just gonna we're just gonna end up appending them to the end of the string each time. And then we'll just end up returning the word. So yeah, pretty easy problem. Um, Pretty intuitive. But yeah, thank you.